In this section, we'll be talking about all the different ways you can load and insert data into DataStax Enterprise Graph. To start, we'll be exploring the Graph API. The Graph API is just one of 5 different ways you can create and load data into existing graphs. Now, while we'll go into depth on all 5 of these topics, in this specific presentation, we'll be focusing on the Graph API. This method is to be used when creating small to medium-sized graphs. One can execute individual statements in the Gremlin console or DataStax Studio, or write a script that issues many statements programmatically. This method is generally slower than the Gremlin IO utility. However, Gremlin IO is more suitable when exporting and importing existing graphs. Gremlin mutating traversals are more suitable for mutating existing graphs. The Graph Loader utility is capable of parsing existing collections of text files and datasets stored in JDBC-compatible databases and loading such data as graphs into DataStax Enterprise. The utility is designed for loading small to medium-sized graphs. There's also a Spark-based bulk loading utility, and it's ideal for loading large graphs. In this specific section, we're going to be focusing on the Graph API, the Gremlin IO utility, and the DataStax Graph Loader. So let's talk more about the Graph API. The 2 main methods you should be aware of to start creating your own graphs are addvertex and addEdge. There are more methods that can be useful in the Graph API, which can be found in our documentation. Addvertex can be specified with a label to add a labeled vertex to the current graph, or you can simply add a vertex where the vertex label and properties are key value pairs. Similarly, the addEdge method allows you to add an edge directed from the current vertex to the end vertex with the label and properties as key value pairs. 2 more important methods to know about are the property and remove methods. The property method allows you to add or set a property for a vertex, edge, or vertex properties. This is applicable to regular, multi, and meta properties as well. The remove method allows you to remove a vertex, edge, vertex property, or even edge property from the graph. Okay, so now that we know the 4 main methods for interacting with the Graph API, let's put it to good use. Here's an example for creating vertices and vertex properties. You can see that we define a vertex U for user, and we call the addvertex method and provide a label and property key value pairs. Let's take a look at another example. This time we're creating a new movie vertex in our killer video reference graph. Just like before, we define a vertex M for movie, and provide the label and property key value pairs. Notice at the bottom, we can add more properties to our vertex M by using the property method and providing the property key value pairs. In this case, production is a multi-property, therefore has multiple production companies involved. It wouldn't be a graph use case if we didn't connect our vertices together, so let's go ahead and do that. Here we're defining an edge E. Notice how we call the U user vertex from before, and the addEdge method with an edge label called rated and the end vertex. Our relationship here is user rated a movie, so we start with the user vertex, addEdge method, edge label, then add the end vertex, in this case movie. We can then take that edge and add properties associated with it using the property method. A user rated a movie with a rating of 8 in this case. Deleting properties, edges, and vertices is pretty simple. You add the remove method to the thing you'd like to remove. At the top here, we're removing the age and gender property from the user vertex we created earlier. At the bottom, we're removing the entire rated edge and movie vertex that we created previously. Here's where things get interesting. Let's say you want to connect a new vertex to an existing one already in your graph. You can easily mix graph mutations with traversals. In our example here, we want to connect 2 users that know each other. We define our first user vertex, U1, and just like in the prior example, this one is using the addvertex method to create a new user. Next, we want to define our second user, U2, which already exists in the graph, so define the traversal that will return our U2 vertex. Just like before, we can take the first user, call the addEdge method with the label, and then the end vertex, which in this case is our U2 vertex. At the bottom here, you can see a more compact version of the above example where we start by adding our vertex, chaining the addEdge method where we define our traversal that will return the existing vertex we'd like to connect to our new vertex. Let's take what you've learned about the Graph API and put it to good use.